All right, this is 6-3 double angle, power reducing, and half angle formulas. All right, so let's look at the double angle identity first. So sine of 2x, we can think of a sine of x plus x. Remember sine of u plus v? That'll be sine x cosine x plus cosine x sine x, which will be 2 sine x cosine x. The cosine of 2x, remember cosine of u plus v? Yeah? We can think of as cosine of x plus x, which will be cosine x minus sine x, which is cosine squared x minus sine squared x. Now, notice what that tells us is we can find the sine of 2x if we know the sine of x and cosine of x. We can find the cosine of 2x if we know the cosine of x and sine of x. All right. Also, if you look at the cosine 2x, which is cosine squared minus sine squared x, remember cosine squared is 1 minus sine squared? So if we replace it with 1 minus sine squared, we can also use 1 minus 2 sine squared x for cosine of 2x. And if we replace the sine squared by 1 minus cosine squared, we can think of that instead of 2 cosine squared x minus 1. So to know the cosine of 2x, we can either know both cosine x and sine x, or just the sine of x, or just the cosine of x. Okay, depending on which of those expressions we want to use. All right. The tangent of 2x is sine of 2x over cosine 2x. It'll be 2 sine x cosine x over cosine squared x minus sine squared x. And if we multiply top and bottom numerator and denominator by 1 over cosine squared x, we get 2 tangent x over 1 minus tangent squared x. Or if you remember the tangent expression from the other section, right? It was tangent of u plus v. So tangent of x plus x would be tangent x plus tangent x over 1 minus tangent x times tangent x. Okay? All right. To verify identities with multiple angles, apply multiple angle formulas first. Okay, so let's look at an example. We'll start example 1 and then we'll go through example 2. Example 1 says, if sine theta is 4/5 for theta in quadrant 2, find the exact values of A, sine 2 theta, B, cosine 2 theta, and C, tangent 2 theta. Let's try sine of 2 theta. So, to know the sine of 2 theta, remember this is 2 sine theta cosine theta, right? So, sine of 2 theta is 2 sine theta cosine theta. So, I have the sine of theta equals 4/5, so this will be 2 times 4/5 times, but I don't know the cosine of theta. Now remember the cosine theta is 1 minus sine squared. Okay, so I'm going to use that formula. Cosine squared theta is 1 minus sine squared theta, which in this case will be 1 minus, and sine theta is 4/5, so squared would be 16 over 25. That would be 9 over 25. That's cosine squared theta. So cosine of theta is plus or minus 3/5, right? The square root of. Okay, now, how do I know which one? Well, in quadrant 2, remember theta's in quadrant 2, the cosine is negative, so cosine theta is negative 3/5. Okay, all right, so this will be negative 3/5 for cosine theta. Yeah, and we have 2 times 4/5 times negative 3/5 would be negative 24/25. All right, for cosine 2 theta, because I have the sine of theta, I could just use that's 1 minus 2 sine squared theta, which would be 1 minus 2 times sine squared theta will be 16/25. Yeah, that'll be 1 minus 32/25. Yeah, of course 1 is 25/25, right? That's right, at 25/25 minus 32/25, that'll be negative 7/25. And remember that this is in quadrant, theta is in quadrant 2. Sorry about that. All right, so that's our answer. Cosine of 2 theta is negative 7/25. Oh yeah. No, so cosine is negative in quadrant 2. Cosine of 2 theta though. Sorry about that again. Sine of 2 theta is negative. Cosine 2 theta is negative. Oh, so they're actually in quadrant 3. All right. Letter C is tangent of 2 theta. You work that on your own. Let's try number 2. Verify sine of 3x equals 3 sine x minus 4 sine cubed x. So again, remember to verify identities with multiples of angles, apply multiple angles formula first. Remember, we have a guideline that says work with the least simplified side first. Well, this tells us no. If we have multiple angles, work with the multiple angles side. Okay. So we're going to start with the left-hand side equals sine of 3x, and then I can say that's equal to the sine of x plus 2x. Would you guys agree? Okay, that'll be sine x cosine 2x plus cosine 2x sine x. All right, that'll equal sine x. And then cosine 2x is, so notice I have sine cubed x, so I'm going to say this is cosine 2x is 1 minus 2 sine squared x. Yeah, do you remember that? Okay. Plus cosine 2x again, which again I'm going to say is, let me see, 1 minus 2 sine squared x. Yep. 1 minus 2 sine squared x. Times sine x. All right, let's see what we can get from that. That'll be sine x All right, let me backtrack a little bit here. I think I made a mistake on this. So this is u v, and this is u and v. So this should be cosine x sine of 2x. All right, so this will be cosine x sine of 2x, then is 2 sine x times 2 sine x cosine x. All right, so this will be sine of x minus 2 sine squared x plus cosine x 2 sine x cosine squared x. Yeah. All right, and I want there to be a 4 sine cubed x. Where am I going to get that from? So this will be sine x minus 2 sine squared x plus 2 sine x. Remember, cosine squared x is 1 minus sine squared x. Yeah. This will be sine x minus 2 sine squared x. I think of sine cubed x. This is 2 sine cubed. No wonder I was like, where's the sine cube gone? All right, plus 2 sine x minus 2 sine cubed x. That'll be 3 sine x minus 4 sine cubed x. And that is the right-hand side. The right-hand side. Okay, let's look at some other ones. Flip the page here. Let's try, first some half-angle identities. All right, so let's just go through these and see where we get these. So remember, cosine of 2x is 1 minus 2 sine squared x, but I'm going to write that y instead of x. So I'm going to say cosine of 2y is 1 minus 2 sine squared y. Then I'm going to solve for sine of y. So first, sine squared y. If I switch the cosine 2y and the minus 2 sine squared y from where they are, that'll be sine squared y is 1 minus cosine 2y over 2. And so sine of y will be plus or minus the square root of all that, right? Square root of 1, plus or minus square root of 1 minus cosine 2y over 2. Now, I'm going to replace y with x over 2, right? So instead of saying sine y, I'll say sine x over 2 equals plus or minus square root of 1 minus cosine. And so 2 times x over 2 will be x all over 2. Okay, so we have an expression to find sine of x over 2. What is this going to allow us to do? It's going to allow us to find the sine of 15 degrees. If we think of it as 30 degrees over 2, that'll be plus or minus square root of 1 minus cosine of 30 degrees all over 2. And by the way, notice that we'll know that it's a positive, right? The sine of 15 degrees has to be the positive. the positive value because the sine of 15 degrees is positive. So we'll be able to identify which sine it is. Okay, same thing for the cosine of x over 2. So we start with cosine of 2x is 2 cosine squared x minus 1, but I'm going to use y, so I'll have cosine 2y is 2 cosine squared y minus 1. Solving for cosine y, and you just go through it, I get cosine y is plus or minus square root of 1 plus cosine 2y all over 2, and replacing y with x over 2, I get cosine of x over 2 is plus or minus square root of 1 plus cosine x all over 2. And again, this lets us find the cosine of 30 degrees over 2. That'll be plus or minus square root of 1 plus cosine of 30 degrees all over 2. Okay? All right. We have a few different expressions for tangent of x over 2. First of all, it's sine of x over 2 over cosine of x over 2, which will be plus or minus square root of 1 minus cosine x over 2 over plus or minus square root of 1 plus cosine x over 2, which will be plus or minus square root of 1 minus cosine x over 1 plus cosine x. Okay? If we take that plus or minus, we can use that, by the way, or we take it and multiply by 1 minus cosine x over 1 minus cosine x and just work through it, we end up with just 1 minus cosine x over sine x. Okay? Notice 1 minus cosine x will be a positive number and the sine x will be positive or negative, and that's how we'll determine the sine. Or we could have taken plus or minus square root of 1 minus cosine x over 1 plus cosine x multiplied by 1 plus cosine x over 1 plus cosine x, top and bottom, and we'd end up with sine x over 1 plus cosine x. Again, 1 plus cosine x is a positive number, and sine x could be positive or negative. Right, I'm going to stop that video here, and we'll continue with some examples in part 2.